Well, we're beginning a new chapter today. We're now in Chapter 4, learning about quadratic functions and equations. The essential units for our unit: what are the advantages of a quadratic function in vertex form? How is any quadratic function related to the parent quadratic function, y equals x squared? And how are the real solutions of a quadratic equation related to the graph of the related quadratic equation? This lesson 4.1 is about quadratic functions and transformations. So the objective of this lesson is students will be able to identify and graph quadratic functions. So first of all, let's begin with the warm-up. I would like for you to pause the video and work these 4 problems, evaluate each function, and then come back and check your answers. All right, we are evaluating f of x equals x for -3. So whatever x is, f of x is, that's what x is. Here we're going to put a -3 in for x. So -3 squared is 9, positive 3 squared is 9. The opposite of x, so the opposite of a -3 is a positive 3, and the opposite of a positive 3 is -3. And this is the opposite of the number squared. So -3 squared is 9, and the opposite is -9. 3 squared is 9, and the opposite is -9. Now the key concepts for this lesson: a quadratic function. It's a function that can be written in the standard form, f of x is equal to ax squared plus bx plus c, where a cannot be equal to 0. And a parabola is the graph of a quadratic function. So a parabola is shaped either like a smiley face or a frowny face. It depends on if your slope is positive or negative. You might want to study these in your notes. We've learned about transformations before of linear equations. Now we're going to look at transformations of quadratics. So it's x that's been squared. Notice it's different if whether it's a vertical or horizontal translation, whether or not it's within grouping symbols or not. So this is within, this one isn't. So that determines whether it goes up or down, left or right. A vertical stretch or compression: a stretch is if a is greater than 1, or a compression if it falls between 0 and 1. And a reflection is whether or not the negative sign is within the grouping symbol or not. The vertex form of a quadratic function is y is equal to a times the quantity of x minus h squared plus k. The graph has a vertex at h, k. Now notice that when it's within the parentheses, it's x minus h, so it's going to be the opposite, or a positive h. The graph has an axis of symmetry at x equals h. This is known as the equation for the axis of symmetry. You have to write x equals whatever the h value is. And the graph opens up if a is greater than 0 and down if a is less than 0. So if this is positive, it opens up. If it's negative, it opens down. So you would have a frowny face. The domain is all real numbers, and the range is determined by the vertex and how the graph opens. So we'll take a look at those. Example 1. We're asked to graph the function f of x is equal to x squared minus 5, and then we're asked, how is the graph a translation of the graph of the parent function f of x is equal to x squared? So first of all, we've got f of x equals x squared, and it's translated 5 units down. It's not within the grouping symbol, so it goes down. Here we have f of x is equal to -3x squared, and again we're asked, how is it a graph of the translation from the parent function f of x equals x squared? Because this is negative, it opens down. That is greater than 1, so we have a stretch by 3 from the parent function. Oh, now we're getting a little bit more complicated, and we're asked what are the vertex, the axis of symmetry, the maximum or the minimum value, and the domain and the range. Well, first of all, the vertex is a positive 4 and -2, so 4, 2, this is the h and the k. Our axis of symmetry, the equation will be x is equal to 4. The minimum is at a -2. We look at our y value. The domain, of course, is all real numbers. The range, since it opens up, because that's positive, from a -2, y is going to be greater than or equal to -2. Let's look at another one. Again, we name the vertex, axis of symmetry, maximum or minimum, and the domain and range. So the vertex is -3, 1. Can you figure out what the equation for the axis of symmetry would be? X equals -3. Excellent, because a -3 right here. How about a maximum or minimum? Look at our y value. Our maximum is going to be at 1 because this is going to be opening down. So 1 is going to be the highest point, our maximum for our graph. Domain, of course, all real numbers for quadratics, and the range. Since it opens down and our highest value is 1, y is going to be less than or equal to 1. Very good. You're ready to begin working on the assignment.